Hello and welcome to my YouTube channel. Today I shall be discussing the topic linear inequalities in two variables and of course system of inequalities. Please hit on the subscribe button below to subscribe to my channel if you've not done so already. Thank you. Now a linear inequality in two variables is of the form ax plus by plus c greater than 0. Of course, where a, b, and c are real constants, that's real numbers, and x and y are the unknown. So here, this is linear in the sense that the highest power of x is 1, and the highest power of y is 1. That makes it linear. It's an inequality because of this greater than sign, and that's it. And we have two variables, x and y. So we could also have less than 0, we could have greater than or equal to 0, we could have less than or equal to 0. For example, we have 4x plus 2y plus 8 less than 0. This is a linear inequality in two variables. You can also have something like say 2y minus 5x plus 10 greater than or equal to 0. This again is a linear inequality in two variables. In our first video, where we treated quadratic inequalities, we observed that the solution of a quadratic inequality was represented in terms of set notations. For example, when we solved the problem x squared minus x minus 30 greater than or equal to 0, we had the following solution. We have minus infinity, minus 5, union, 6, and infinity. So the solution to the inequality, which was quadratic, was represented using sets. However, when it comes to linear inequalities in two variables, we do not use sets anymore to write down the solutions. Rather, we put the solutions down in what we call solution regions. Therefore, the solutions to linear inequalities in two variables are written down on solution regions. I'm now going to take you through a step-by-step approach on how to get such regions. Step 1. We make y the subject of the inequality given to us. After doing that, step 2, replace the inequality with the equality sign. Then step 3, we'll obtain two coordinate points, x1, y1 and x2, y2, and mark those points in the xy plane. I'm going to explain. Then the next step, we join these 2 points which we've already found from step 3 with a broken line if our inequality is less than or greater than. And if the inequality is less than or equal to or greater than or equal to, we'll draw an unbroken line to link the 2 points. Finally, we shade the region below the line if the inequality is of the less than form, and above the line if the inequality is of the greater than form. We shall take one or two examples to clarify and show how these steps can be put to play. Example 1. Find the solution region for the following inequality: 2y minus 4x plus 5 greater than 3. So clearly, this inequality is linear and is also in two variables, x and y. So we want to solve this by finding the solution region. So we shall take the steps one after the other. So step 1 says we should make y the subject of the inequality. So to make y the subject simply means to make y to stay alone. So to do that, we shall send every other thing to the right hand side. So we have here 2y greater than there's 3 here. This is minus 4x to the right becomes plus 4x. This is plus 5 to the right becomes negative 5. So that 2y is greater than 3 minus 5 is minus 2. So we have here 4x minus 2. We want to make y the subject. So we'll divide all through by 2. If we do that, we'll have that y is greater than 4 divided 2 is 2x minus 1. So we have just made y the subject of the inequality. So y is greater than 2x minus 1. Y now stands alone, just on its own. Hence, it has been made the subject of the inequality. Step 2 says we should replace the inequality with equality sign. So instead of writing y is greater than 2x minus 1, we'll now be writing y is equal to 2x minus 1. And of course, this becomes a line in geometry. Step 3 says we should obtain two coordinate points, x1, y1, that's the first coordinate point, and x2, y2, and mark those points in the xy plane. Now, this is what we're saying there. We're going to have our xy plane like this. So where this is our y-axis, this is our x-axis, and of course, this is the intersection 0, 0. So we want to find 2 points. The first point will be x1, y1. Second point could be anywhere, x2, y2. Now, what we do is this. These 2 points could be any 2 points on that line y equal to 2x minus 1. So what we do is, to make life easy for us, these 2 points here, this point rather 0, 0 is a point that is common, to both line y and x. So to make life easy, we simply put x equal to 0 to get the first point and put y equal to 0 to get the second point, as follows. Now the line is what? Here we have y equal to 2x minus 1. We want to get 2 points. So to get the first point, I'll put x equal to 0 into this line, which I'm going to call equation 1. So put x at 0. If you put x at 0, you have y equal to 2 times 0, since x is 0, minus 1. So that y is equal to 2 times 0 is 0, minus 1. So that y is equal to minus 1. Now there's a coordinate at that point. What's the first coordinate? When x is 0, y is what? Minus 1. That is our first coordinate. That's our first coordinate. And please take note, this coordinate here is an ordered pair. The word there is ordered. It's an ordered pair. Ordered pair in the sense that the first entry of this coordinate must be for x, and the second one is for y. So in other words, if you write this as minus 1, 0, then that would be wrong, because that would mean that x is minus 1 when y is 0. Now to get the second coordinate point, you put what? Y now. You put y equal to 0. There are other ways of doing it, but to me, this is the simplest approach to the problem. You put y equal to 0, still into 1. So that becomes 0 rather, equal to 2x minus 1. So if we take 1 to the left, we have 1 equal to 2x. To find the value of x, we divide both sides by 2. Therefore, x is equal to what? Half. So the second point now will be what? When x is half, y is what? Y is 0. So we have our 2 points, 0, 1 and half, 0. And what are we told in step 3? We are told to mark the points in the xy plane. So let's go to the xy plane and do just that. So this is my xy plane, positive y-axis, negative y, positive x, and negative x. So I want to mark the point, the coordinates we have obtained. What's the first coordinate? We have 0 and minus 1. So 0, this means when x is 0, y is minus 1. So let's trace that. This is the origin. So when x is 0, y is minus 1. Minus 1 is downwards. So let's assume this is the point here. That's the point 0, minus 1. So we've marked that point. The next point is what? Half and 0. When x is 1 over 2, y is 0. So we trace that other point. This is the x-axis. When x is half, let's just call this point half. Y is what? 0. When x is half, y is 0 on the line. So when x is half, y is 0. So these are the 2 points we have marked on the xy plane. What is the next step? Next step says we should join the 2 points which we have just marked on the line with a broken line if our inequality is strict. And we should join the 2 points with an unbroken line if our inequality is not strict. So let us go and see. In the problem given to us, our inequality is greater than, and this is a strict inequality. So what that step is saying is that if this inequality here is strict like this one is, we should now join those 2 points with a broken line. And if this inequality was not strict, we would have joined the 2 points with an unbroken line. So let's go back to our xy plane. So since our inequality is strict, we will join these 2 points with a broken line like this. Those 2 points. And of course, we can extend this line, to any point that we wish to. That's what the step says. Now, this is what the line y equal to 2x minus 1. You should always label the line. Now, this is a straight line. This is line y equal to what? 2x minus 1. Now, the final step. We should shade the region below the line if the inequality is less than. And we should shade the region above the line if the inequality is what is greater than. So let us see our inequality. Our inequality is greater than. So from what step 5 says is that since inequality is greater than, we should shade above the line. So we'll go back to our xy plane. So this is below the line, while this is above the line. So we now shade above the line like this. We now shade above the line. And what we have here, the shaded region here, from here, it extends, of course, to infinity, whatever that is. And this line also keeps going, and that's it. So the shaded region here is what we refer to as what? The solution region for the given inequality, which is what? 2y minus 4x plus 5 greater than what? 3. What this means is that in this region, whatever point you pick in this region, such point will satisfy the inequality. Now let's see. Let's just pick one point. This point 0, 0. Of course, 0, 0 is already in the region, as you can see. So let us see if this point 0, 0 satisfies the inequality. Let's see. So 0, 0 means that x is 0, y is 0. So let us put x as 0 and y as 0 here and see what happens. So this is 2 times y is 0 minus 4, x is 0 plus 5. 2 times 0 is 0 minus 4 times 0 is 0 plus 5. 0 minus 0 plus 5 is 5. And 5 is greater than what? 3. So this point here satisfies the inequality. This is just one point out of more than a billion number of points. So whatever point you pick, let's pick one more point so that we can be clarified with this. Let us assume we pick a point here. Now let's assume this point is, say, minus 3 and say 1. Okay, or let's just say 2. This point is minus 3 and 2. So x is minus 3, y is 2. Let us see if it satisfies the inequality. So 2 into y, or y is 2. 2 minus 4, x is minus 3 plus 5. Let's see where it takes us. So 2 times 2 is 4, minus 3 times minus 4 times minus 3 is plus 12 plus 5. So 4 plus 12 is 16. 16 minus 5 is 21. And once again, 21 is greater than 3. 21 is greater than 3. So the point we've taken, minus 3 and 2, again is another point that satisfies the inequality. And of course, if you pick any point you pick in this region, such a point will satisfy the inequality. That is why it is impossible to bound, the solution. We cannot bound it like we did in the previous, in the previous case of quadratic inequalities. So here we talk about what? The solution region. Because whatever point you pick in the region, which we call the solution region, satisfies the inequality. So we'll now take a second example to clarify us, better. And now we'll make it a little bit faster. Example. Find the solution region of y minus 2x minus 3 less than or equal to 0. This again is an inequality and it's linear in two variables. So we have y minus 2x minus 3 less than or equal to 0. Our step 1 says we should make y the subject. So y is less than or equal to, this is minus 2x to the right becomes 2x. This is minus 3 to the right becomes plus 3. So we have already made y here the subject of the inequality. Our step 2 says we should replace the inequality sign with equality sign. So we now write y equal to 2x plus 3. And that becomes a line. Step 3 says we should now find two coordinates, okay, and mark those coordinates on our xy plane. So like I said earlier, it is advisable to just pick the point 0, 0. This point means that x is 0, y is 0. So for my first coordinate, I'll simply put x as 0 into this equation, which I call 1. So if I put x as 0, this becomes y equal to 2 times 0 plus 3. So that y is equal to 2 times 0 is 0 plus 3 is 3. So I have my first coordinate. Now what's the first coordinate? When x is 0, y is what? 3. Recall that this is always an ordered pair. So my first coordinate is that when x is 0, y is 3. For the second coordinate, I will now put the value of y as 0. I will now put y equal to 0 into 1. So that becomes y is 0. So this is 0 equal to 2x plus 3. If I take plus 3 to the left, I'll get negative 3 equal 2x. If I divide both sides by 2 so that I can get x, I will get that x is equal to negative 3 over 2, which I can see right as minus 1.5. So with this, our second point is ready, which is what? X is what? Negative 1.5, and y is what? And y is 0. So we got our two coordinate points. The next step now is to go to our xy plane and represent these points. So I'll just draw the xy plane here. This is my xy plane. This is your positive y. This is your negative y. Positive x and negative what? X. So the first point is my origin. Remember, this is 0, 0. So when x is 0, y is 3. That's the first point. When x is 0 here, y is 3. Y is 3 somewhere here. Let's call that point 0, 3. This first point. The second point is when x is negative 1.5 is this way, y is 0. So when x is negative 1.5, let's say somewhere here, y is 0. So negative 1.5 and y is 0. The next point is for us to join the line. So rather, join the 2 points. However, we must be careful. We must ask ourselves, are we to join the 2 points using broken lines or unbroken lines? We check the nature of our inequality. That's what tells us. So our inequality here is not strict. It's less than or equal to. And when we have this kind of inequality, we join the 2 points with unbroken lines. So we join with unbroken lines. And of course, we can stretch this line, beyond those 2 points to any length. The next thing we want to now do is we want to shade the solution region. There are 2 sides, on the line. Of course, this is the line what? Y equal, where is it? The line y equal to 2x plus 3. The next step, which is the final step, is to shade which of the regions is a solution region. And that will be either the region below the line or above the line. And once again, we go back to our inequality to check. Our inequality is what? Less than. And when it's less than, we shade below the line. When it's greater than, we shade above the line. So in this case, it's less than. So we shall shade below the line. We shade below the line. So this, region that's shaded, of course, it extends to any point below the line. This line can also extend, like I already explained. So any point we pick in this region, which we call our solution region. So we call this point here our solution region. So any point we pick in this solution region will satisfy our given inequality. So we shall check with just 1 or 2 points. Once again, the first point we find there is 0, 0. So let us check. So when y is 0, x is 0. So we have y minus 2x minus 3. So the point 0, 0, y is 0 minus 2, x is 0 minus 3. So this is 0, this is minus 3. Is minus 3 less than or equal to 0? The answer is yes. Because minus 3 is actually strictly less than what? 0. So that means the point 0, 0 is indeed in the solution region. And of course, we can pick any other point in this region and check if it satisfies the inequality. I'd like to make the following remark at this point. Now in the previous example, we saw that our line was a broken line, y equal to 2x minus 1. And in this other example, our line is an unbroken line, y equal to 2x plus 3. Now the fact that they are unbroken or broken has a meaning. Now the broken line indicates that this line here is not part of the solution region. So what it means is that all the points that lie on this line are not in the solution region. So whatever point that you're able to pick on this line will not be in this region. While the second example here, where the line that joins the 2 points is unbroken, it simply means that the points on this line also satisfy the inequality. Let us see. There's one point on this line. What point is that? 0, 3. Let's check if this is also in the region. So 0, 3, we have x is 0, y is 3. So y is 3 minus 2 times 0 minus 3. So this is 3. This is 0 minus 3 equal to 0. So is 0 less than or equal to 0? The answer is yes, because 0 is equal to 0. So it satisfies. So you have seen that this point 0, 3 that lies on the line is also in the solution region. If you check the second point, minus 1.5, 0, you observe that this point also will be in the solution region. But let us check for the other example and see what happens. In this example, one of the points we had on the line was 0, minus 1. So 0, minus 1. So x is 0 and y is what? Negative 1. So let us check if it satisfies the inequality. So we have here 2 into y is minus 1. So minus 1 plus minus 4 into x is 0 plus 5. Let's see. 2 times minus 1 is minus 2. This is 0 plus what? 5. Minus 2 plus 5 is 3. Is 3 greater than 3? The answer is no. 3 is not greater than 3. So that tells you that the point 0, minus 1 that is on the line is not in this region. So that is what happens when the line is broken. It simply tells you that all the points on that line are not in the solution region. And when the line is not broken, it tells you that all the points on that line are also in the solution region. If you check the second point, which we know already, that is 1/2, 0, you see also that that point will not be in a solution region. System of inequalities. A system of inequalities comprises of two or more inequalities in one or two variables. Now, and to obtain the solution region, what we'll do is we'll draw a line for each inequality given to us, as we had described earlier, and then the intersection of all the regions becomes our solution region. Let us take an example very quickly to understand what I'm really saying. Example: find the solution region which satisfies the following system of inequalities. The first one is 2y plus 3x minus 12 less than or equal to 0. Second one is y minus 2x plus 3 less than 0. And the third one is y is greater than what? Minus 2. And you have seen here that we have more than one inequality. So that becomes a system of inequalities. So we're going to solve, these inequalities and then show the solution region for them. So the first one is 2y plus 3x minus 12 less than or equal to 0. And what's the first step? First step is to make y the subject of the inequality, right? So we have here 2y is less than or equal to, this is plus 3x to the right becomes minus 3x, this is minus 12 to the right becomes plus 12. Now to make y the subject, we'll divide through by 2, divide through by 2. So we now have that y is less than or equal to negative 3 over 2x plus 6. For the second one, let us make y the subject also. We have here y minus 2x plus 3 is less than 0. So we have y is less than minus 2x to the right is 2x plus 3 to the right is negative 3. So y is the subject already. For the third one, we have y is greater than what? Minus 2. For this one, y is already the subject of the inequality. So for the three inequalities we've made y the subject of the inequalities. What's our next step? Our next step is to replace the inequality sign with what? Equality sign. So for the first one, we now have y equal to minus 3 over 2x plus 6. For the second one, we have y equal to 2x minus 3. And for the third one, we have y equal to negative what? 2. So the next step is to what? Is to find two coordinates which we are going to mark on our xy plane. Like we did earlier, we put x as 0 first, then put y as 0 later. So for the first one, when we put x as 0, we'll put x as 0 here, put x as 0. What do we have? We get y equal to, when x is 0, 0 times whatever this is 0. So y equal to 6. So when x is 0, the first point we get here is x is 0, y is 6. Remember that this pair is an ordered pair. For the second point, we put y as 0. So when y is 0, this becomes 0 equal to minus 3 over 2x plus 6. So if we take plus 6 to the left, we get minus 6 equal to minus 3 over 2x. So that when we solve this, we get x equal to 4. Then the point here becomes when x is 4, y is 0. For the second line, we put again x as 0. So here we put x as 0. So we have y equal to when x is 0, this becomes 0. 0 times 2 is 0, so minus 3. So the first point again we see there is x is 0, y is what? Minus 3. And for the second point, we're going to put y as 0. So we'll now put y as 0. And we'll now have here becomes 0 equal to 2x minus 3. So that if we take minus 3 to the right, we have 3 equal to 2x. Divide through by 2, and your x is equal to 3 over 2, which is what? 1.5. So the second point there is simply what? X is 1.5, y is what? 0. For the third one, we have y equal to minus 2. This is just a line. Y equal to minus 2. This is just in one variable. Y equal to minus 2 means a straight line. So at the point minus 2, we shall just draw a line. I shall show you. So now we have our points. We'll now go to our xy plane to mark these points. So this is my xy plane on which I now mark my points. So for the first line, I have 0, 6, 0, when x is 0, y is 6, x is 0, y is 6, so somewhere here. So 0, 6, 0, 6, and the second coordinate there is 4, 0, when x is 4, y is 0, when x is 4, 4 is somewhere here, y is 0, so 4, 0. The next thing now is we join the points. But the question is, do we join the points with broken lines or unbroken lines? We go back to our inequality and check. For that particular one, the inequality is what? Less than or equal to. Less than or equal to. And when it's less than or equal to, what do? We join the point using what? Unbroken lines. So, we join these 2 points using unbroken lines. And of course, remember the line can extend, away from the point. The next question is, do we shade below the line or above the line? We check again. We have less than. And once we have less than, we shade below the line. So this is the line. So above the line will be this way, and below the line will be this way. But before then, what line is this? That is the line y equal to what? Minus 3 over 2x plus 6. So we now shade below the line. I'll now use red ink to shade below this line. So I shade below the line this way. So I've shaded below the line. For the line y equal to minus 3 over 2x plus 6. So what this means is that every point, in this region satisfies the first inequality. This one, 2y plus 3x minus 12 less than or equal to 0. Remember, the line is unbroken. So this means that if all points on the line also satisfy that inequality. We'll now move on to the second point, to the second inequality. The points are 0, minus 3. So x is 0, y is minus 3. On the same xy plane, we'll point out those regions. The points, rather. So 0 and minus 3. When x is 0, y is minus 3. Y is minus 3. That is down. So somewhere here. Somewhere here. So when x is 0, y is minus 3. Somewhere there. The second point, when x is 1.5, y is 0. When x is 1.5, let's just call somewhere here, 1.5, y is 0. When x is 1.5, y is 0, somewhere there. So now join. With broken line or unbroken line, we check the inequality again. Our inequality this time around is a strict inequality. So we can only join the 2 points using a broken what? Line. So these 2 points will be joined using broken lines to tell us that the point on the line are not included in our solution region. So we do this broken line. The next question is, do we shade below the line or above the line? Of course, we go back to check less than. Since it is less than, we must shade below the line. So this is our line. What line is this? This is the line y equal to 2x minus 3. So since we have less than, so we shade below the line. So I'll use red ink now to shade below this line. So I have this, I have this. So on the line y equal to 2x minus 3, I've shaded the region below the line to signify that that is the solution region for the second inequality, y minus 2x plus 3 less than 0. And what this means is that any point we pick, below this line will satisfy the second inequality. Now we now move to the third line. The third one is y equal to what? Minus 2. Like we said, this is just a line. So there were no 2 points here. So this simply means that this is the line y equal to minus 2. So what we do is we go to our xy plane at the point minus 2. We locate, that line. So this is y is minus 2. Minus 2 is below. This is minus 3. So minus 2 is before there. So let us call this point here minus 2. So at y equals to minus 2, we draw a line that is parallel to the x-axis. Take note. At y equal to minus 2, I repeat, you draw a line that is parallel to the x-axis. If this was to be x, we would have drawn a line that is parallel to the y-axis. If this were to be x, it would have been here. X equal to minus 2 should have been somewhere here. The line would have been drawn like this, parallel to the y-axis. But for this one, we have y equal to minus 2. We'll now draw a line that is parallel to the x-axis. The question now is, will the line be broken or unbroken? We check the inequality. Inequality is greater than, so it will be what? A broken line. So it will be broken, so we break it. We break the line, that is it. Parallel to the x-axis. We break it this way. So this is the line y equal to what? Negative 2. So now think of how to shade. Should we shade above the line or should we shade below the line? We check again. The inequality is greater than. And once it's greater than, we must shade above the line. So for this line, I'll shade above. So I've shaded above the line to indicate that that is solution region for the inequality y greater than minus 2. The question now is, where then is the solution region for the system of inequality? If you look closely at this region, you observe that there's a region here, this triangular shaped region here, somewhere here, where the 3 strokes meet. Look at the black strokes here in this region. Look at the other stroke for this other region. Here the 3 strokes in this region here, all the strokes meet at this point. So this region where the 3 strokes meet become the solution region. When you plot this region by yourself, you see better what is happening. So what we do here is we draw the lines for each inequality and shade the regions that correspond to the solutions. After that, the region where the point where all the regions intersect become our solution region. And that is how we solve system of inequalities. Please don't forget to leave a like and a comment on this video. Thank you and bye-bye.